Hey folks, how's everyone going today? We have Debix again, and we're doing something different. So I don't know if you recall Debix, but we have looked at them before. It was just a smaller burgundy device, and I'll put a link somewhere up there to it. These are the Debix SOM A IO boards, and Bs and Cs. And of course, we're doing it a little bit differently. We are putting the camera over here this time, as was suggested previously, and I'm also going to try editing my audio a little bit differently because last time it was a little bit muffled, but I still want to improve, of course. Lighting, camera, action, all of that. But getting on to the product. Debix make industrial hardware, which I find amazing. This is what we looked at last time. This is the Debix Model C. I put it in the air fryer, I put it in the freezer. We literally torch tested it and this thing held up. So now they were kind enough to reach out to us and ask if we wanted to do it again. This time though, they've sent a pile of them and I'm going to be giving some of them away. I'll give you more details on the giveaway a little bit later in the video, but we're going to be testing it out. Essentially, we've got a pile of carrier boards. We've got a pile of the SOM modules, and they do some pretty cool stuff, which I'm really, really excited about. This is sponsored though, and it's probably worth me saying that. It's not sponsored in the normal way. There's not going to be any PCBWay ad read. This is sponsored by Debix themselves. Now, in short, the way that that works is they are paying me to make this video. There were some conditions attached though, and that's why I want to be completely honest and open with you. They're not paying for me to say anything. In fact, they've given me all of this, and in theory, they're going to give me some money afterwards to just do what I want. They understand that they can't provide any script, that if I don't like something, I'm going to say it, that if it doesn't work, that's what you're going to see. They're confident in their products and how I present to just let me roll with it. They won't even get to review the video before it goes live. And that's because I, of course, want you viewers to experience or to see what you're going to experience when I experience it. And that's great. I love working with companies like that. So thank you in advance to Debix for that. Thank you to Debix for also sending 6 modules and 6 boards. I will be keeping 2 and giving 4 away, as I said. What I did forget to mention last Friday, though, was that my channel just had its 3rd birthday, which is awesome. I put a little post out about it, but yay to us. I've been doing this for 3 years now. And for my cooking channel, if you haven't seen it, that is now 7 years. So very, very interesting times ahead and times happening now, especially if you've seen the recent video on Zia2 by Patch Lacey, a great YouTuber who kind of talks about some of those changes. And if you're watching on a TV at the moment, those changes involve you. So straight off the cuff, this is the B and the C SOM system on module. I'm going to put these aside for the next video, and you'll see why, because I'm going to try to keep this at about 20-ish minutes, make it nice and dense and compact, something that you can follow, hopefully, because these are a complex beast. So we'll put these 4 aside. These are the ones that are going to be given away. We'll put 4 of these aside, and we're going to have a tinker with these. And the reason it's a bit mismatched is because they've pre-installed one of these with SOM A on it with Windows. So this is a SBC, an industrial SBC that supports Yocto, Android, Windows, Ubuntu, and Debian. I ran out of fingers, so I started counting backwards there. And they do a great job at it too. So I'll get those both out and we'll go through the specs and then we'll power one up and see what happens. For those of you that like unboxing, actually, I just thought I'd quickly show you. You've got your package here with your board in there, but then you've also got a bit of foam and you've got all the cables. In the event that you don't have a board already on there, you also get a little set of screws, which I thought was pretty awesome that it comes with thread glue already on there. So when you screw it in, it's going to be screwed in well. And that's why I haven't used them yet. To get those out of the way, we're going to have 2 boards here. I'll sit on this foam to start with because I'm still a little precious of this new desk. And of course, we'll take it off the foam when we power it on, just in case that's anti-static foam, which means it conducts. So this one, they have pre-assembled for us. You can see here it has this module already on there. That means it's got Windows. If we grab this other one out, here we go. These are pretty much the exact size bags for them, so it's very tight fit. We now have our 2 SOM IO boards, and the most important bit is the bit that actually does the thinking. That is the SOM board itself. These are sometimes referred to as carriers or IO boards or system on module boards. And this, of course, is the system on module. So what you might notice here as well is that this doesn't look like your normal CM4. It's of course about the same size, but it has a different connector on the back. So it's not your normal 200 pin B2B connectors that you might be used to. These are 80 pin B2B connectors, and there's 4 of them. So it's very dense I/O, but it's also not compatible with Raspberry Pi CM4 and things like that. This is a different beast. Now, if we're going to get into the specs of this one first, which is probably a good idea to be honest, it is a pretty standard board in a way, but with some very special features. So it's a IMX8M SoC, and that's got 4 Cortex A53s. It's then got a M7, so Cortex M7, that's your real-time operating system core. It's got dual ISPs, and it supports between 1 and 4 gig of RAM. So this one here has 2 gig of RAM, and I believe this one here with Windows has 4 gig of RAM. You can order it to your specifications. Looking at the board itself, you've got a few more things as well. So of course you've got the connection here for the carrier. You've got the Wi-Fi module, which is supported on some operating systems, and you've got a massive host of connections around the outside. That's probably going to be the first thing that you notice. That's because these support a lot of interfaces, and this is almost a bit like a dev board or an Evel board, where it's going to allow you to experience everything that the system on module can do. The reason for that is, as I said, they're industrial. They're rated to take a beating as far as environment goes, and they are also designed for those industrial environments. So first of all, you can see there's 2 Ethernet ports. They've got their MAC addresses stuck on there. And what's impressive about these 2 Ethernet ports is that one supports time-sensitive networking, back on the industrial bandwagon. TSN gives you predictable control over your packets or your frames, and allows you to do some more specific, or obviously time-sensitive networking. That goes hand in hand with the 10-year guarantee that NXP have for these SoCs. You've then got all your ports around the outside. So those include LVDS. You've got, I can't remember off the top of my head, but you've got some RGB ports. You've got 2 CAN ports. You've got serial ports. We'll get into them when we have a look at the specs in a tick. We've got a barrel jack here for our power supply. That's 8 to 36 volt. 12 to 36 volt, I should say. So that's going to support most power inputs that you might use. It's not power delivery, because you're not going to be connecting a USB Type-C plug, to a board like this in an industrial environment typically. There are some additional pads here for a dedicated power header, it appears, which is dual 12 volt and dual ground. Now, we've also got audio interface, HDMI, 4 USB 3.0. Both those networking ports are gigabit networking. On the top, we've got the SD card slot. And on the bottom, we have a SIM card slot, a micro SIM slot. That's because of this mini PCIe interface. So you can put a 4G module on there, and I do have some of those in stock, and then use this as a completely headless distributed board for your sensor environments or whatever you want to connect. These connectors here are MIPI CSI and MIPI DSI connectors. So dual MIPI CSI quad lane, and that goes with the dual ISPs running in these SoCs. So you can do real-time image processing, networking, everything like that with what this has built in. The one over here is the exact same board, just with the SOM A 4 gig that they've pre-flashed for us with Windows 10 IoT. So we'll boot up to that and give it a go, but they're quite clearly really impressive little devices. I'll jump over now to the computer so that we can actually have a look at the spec sheets. You can download these spec sheets yourself. I'll put the links below, so I'll go over them very quickly. What we missed saying before was that you've got your 2 PoE inputs here as well. So if you're going to hook these up with PoE, you've got that option. Going around the outside clockwise, we've got that power supply. That was missing the header. You'd have to attach it yourself. LED and key, I2C, more USB. They're USB 2.0, so just your standard 4 pins. Sony Philips digital interface, debug TX-RX, a port for the real-time clock. You've got DO and DI ports. You've got RS232/485 ports. I believe you can only configure 2 of those at once though. I'm not sure why, it's just what I read somewhere. Your 2 CAN ports, LVDS, backlight control, left and right speaker, line in. So a bucket load of connections on this. Plus your dip switches, so they're your boot modes, and that mini PCIe interface I told you about. Looking over at the SOM A, If we jump down, it goes over a little bit. This does have a GPU built in. It's got that real-time core that we're talking about. It also supports FreeRTOS, of course, OpenWRT, which I forgot to say, and the Android version, as I mentioned, is Android 11, currently available for download. You've got those cores that we talked about, the RAM options, eMMCs up to 256 gig. These ones, I believe, have 16 gig on them by default, and then all those interfaces. So you can see here, there's the multiplexing there, and somewhere I believe it mentions the RS485 or RS232 interfaces. But I'm not going to go through reading this whole thing again like I did yesterday. You can see here as well, we have those standard, pretty solid temperature ranges and even enhanced temperature range capabilities, or essentially you should be able to put them in that environment and it will work. There is, of course, humidity as a factor there, which isn't mentioned, but we will find out, that's for sure. So now, for this first test, let's go with the Windows board. This has the onboard eMMC already flashed, so that's what we're going to use as compared to using the SD card image. For this, I'm going to connect the HDMI interface. I'm going to grab, reaching around to the other desk, my receiver for the keyboard and mouse. You can get that over here. And then, because it doesn't have a USB PD trigger, I've just got these, USB PD Type-C port. I've just got these PD triggers that I'm going to use. So this is the 12 volt one. Of course, because of its support up to 36 volt, you could use many of the others. Now we'll connect that and we'll jump over to our HDMI input. The HDMI input looks a little bit different this time because I'm just using a USB capture device. It's not the best, so I apologize for that quality, but I'm having some issues with my Blackmagic and I might have to replace it. It's a tad aged. Instantly, Windows 10 booting up beautifully, which is exactly what we want to see. I'm not skipping forward here either. This is giving you a good idea of how quickly it boots, of what sort of performance to expect. And do remember, this has got no heatsink on it. This is just raw SoC in the air. Back to the HDMI interface. We have a black screen, but I believe it's going to come good in a second. It's probably the GPU drivers or something initializing. There we go. And it's logging in. So yes, the color is slightly off. Yes, there is some compression and artifacting, and yes, it's low resolution, but don't blame Debix for that. That is on me with the USB capture card that I'm using, which was cheap on eBay, I believe. I'll have to order something new after this video so that we don't have the same problem next time. This has also just installed updates. I booted this before to make sure everything was working as expected. So it's likely just a bit slower due to those updates. But we have Windows working on a embedded SBC almost, or an industrial SBC or industrial dev board. I just plugged a network interface in, so we've got the internet. But if we go and have a look at Task Manager and have a look at what's going on. So we have our iMX8 MP with 4 cores at 1.6 gigahertz. So this is Windows 10 IoT running on ARM. So these are Cortex A53 cores. We've then got the 8 gig of RAM that we're talking about. We have our i.MX GPU device, as you can see here. So there is that dedicated GPU. This isn't a gaming rig by any means, but it's just enough to run HDMI. And we've got our Samsung NVMe, or sorry, not NVMe, sorry, eMMC. So that's a 16 gig eMMC. Now remember, this is an industrial device. This isn't a daily driver. This isn't what you're meant to be using just to get stuff done on. This running Windows and launching Edge as we are now just shows what it's capable of. But this is meant to withstand rough environments, extreme use cases with whatever industrial connections you want for like SCADA/PLC and similar critical infrastructure. It's also, of course, great for tinkering and hobbyists, but it's not designed to just be running, Edge and watching YouTube videos. You'll see if we look at the About GPU section, there's not much hardware acceleration going on. The HDMI output is purely for the sake of debugging or interfaces or interaction, like maybe some HMI interfaces or something like that. But don't get upset if you can't watch YouTube videos on it reliably, or if this thing isn't the best at whatever it is you're trying to do that's not an industrial use case. And I'm not going to take watching YouTube videos at work as an industrial use case, but that showed at booting Its power consumption is pretty low, but we're going to measure it. It shows Windows 10 IoT running on the ARM hardware. It shows networking, USB, and HDMI working. Again, remember, it's my capture card here that's at fault. Don't blame the Debix. And it just works out of the box, essentially. What we're going to try next is Debian, which we're going to do with this other one. The way we're going to do that, though, is with an SD card that I've already pre-flashed with their Debian image. So I'm going to quickly rearrange that, and we'll have a look. Now, something possibly worth demonstrating is that these interfaces do also press together a little bit differently. So they're not really keyed. You could accidentally put them in slightly off center or the wrong way around. What you want to do is align the text with the text and make sure you align the hole with the hole. When you push it down, it doesn't really crunch in like a normal CM4 or CM5. It just kind of firmly presses into place. Little bit different there. Now, if I can find my SD card that I lost just before, there we go. We've got a nice little spring-loaded SD card slot there, and we're going to take much the same approach. We'll reconnect all of these things, and then we'll put some power to it, and we'll see what happens. Now, the benchmarks I'm going to do in Windows and Debian. There we go. Power, camera, action, all of those things. There we go. We've got a nice Debix splash screen and it is booting. This is Debian 12, and again, remember it's ARM64. And she's live. That was it. Booted a bit quicker than Windows. You can see it's already picked up the networking. You can see HDMI is obviously working, and as is USB. So now let's go and have a look at terminal. And if we go cat proc CPU info, we have our 4 cores there along with the extensions that they support. What I'm really curious about is how it's set up. So we've got 2 GB of RAM, no swap configured by default, and we have 64 gig there. It's expanded to use all of that card. That's excellent. All of /boot is used up though. So let's have a quick look there. Oh yeah, there is a few device trees going on. There's a lot of stuff in boot. Boot's very full. So that's something they could possibly optimize with the image a little bit. And the biggest question is it's a 6.6 kernel. So that is pretty bloody awesome. I very much like having a 6.6 kernel. Chromium web browser. Whilst we're at it, let's see if we've got some GL Mark II ES2 Wayland. Whoop. All right, all of that can go away for a tick. Wayland. So we have the Vivante GC7000UL. That's the graphics card, but it does do hardware accelerated 3D, it looks like. That's, yeah, 400 FPS, fairly smooth. The issue you're going to hit is much the same as we're talking about in Windows. It's just that Chrome is, of course, going to be very specific about what it wants to do with what. You can see we've actually got hardware accelerated options here. The reason for that is because I have forcefully turned it on in the flags. That doesn't mean that you're going to reliably have GPU though. You can see that it's having some problems. So it's often worth testing, but it often doesn't do what you want. You'll see if we relaunch this now and go back to the still don't want to deal with the keyring, and go back to the Chrome GPU, it's much the same as what we had in Windows. And the reason is it's not meant for that. I'm going to keep saying that because people always whinge and moan in the comments about what it is and isn't doing. What we want to now see though is the power consumption. So I'm going to move this slightly out of the way. We're going to use our FNB 58 and we're going to run it through that because I can see up there on my Pine Power that it's drawing about 3.6 watt, which is bloody impressive for something that's doing this much. But we want to have a look a bit closer. So the old unsafely remove, we're not waiting until it's safe to turn off your computer, and we're just going to get this one in line. I'll be back in a second. And away we go. Some character on some TV show once said, I think. So this is booting up now. 4 watts, as I said. 300 or so milliamps at 12 volts. We have 4 to 5 watts down as low as 3 watts. What's it doing? If we go to HDMI, so it's booting now. That's as much as it probably wants to consume. and it's sitting in that 4 watt range, which is bloody impressive. You could run this off your car battery for such a long time. Whoop, just touching the 5 watts. Now back down to 3. So I'm going to assume, with how that's looking, with this little blinking light and with that sitting around the 4-ish mark, that's going to be about at the desktop, which it obviously is. We're not stress testing it at this point, but we will be doing that, not on video because it takes forever. But what I'm going to do at this point is run Geekbench on both of these. And I'll put the links to those results below because it'll be very interesting to see what sort of benchmark results and performance we get, especially Windows versus Linux, which comes up a lot. You can't pay 100% credit to the results though, because remember, Windows is not optimized, especially Windows 10 IoT is not optimized for ARM, whereas Debian is going to probably work a lot better. That being said, if we get better results in Windows as far as Geekbench goes, I will be very surprised. Don't forget though that I am going to be giving some of these away. And so for that, we will do a second video eventually. In that video, we're going to be looking at the B and C versions, that is. We're also going to torture test it, as I said that we would. And that'll give us a good idea of, you know, what sort of environment are these going to withstand? That's what I did with the Model C video, which we've looked at previously. So I'm going to do the same thing again with this. Debix know that I might destroy their products. That's how it goes sometimes. You might be curious though, if you don't get into the giveaway and you don't win one of these, where can you get it? And that's a very, very valid question, but they are thankfully available for purchase. If we jump over here, you can see that amongst others, RS Online stock them, and they're quite affordable, ranging from 60 to 120 bucks per piece, or they're 170. They even have a fully built one for 490 that they just don't have in stock at the moment, but it gives you the idea of what you can get. I don't know if the BNC is even out yet since they're not listed here, but they've got a lot of really good documentation. They've got really great instructions. Like something I haven't even touched on is that if you're going to be booting to there we go, zoom in a little bit. Which one's my zoom button? That one. Booting to the eMMC, you've got these dip switches here, and that's what configures what you're booting to. So SD card or eMMC can be changed by that. If you don't have an image, of course, it's going to boot to the next medium. It can, depending on how the bootloader is configured. They do have good documentation that covers all of this. So if we look up Control F0010, you can see it explains here for eMMC, that's what you need to have set. They also go through all the different ways to flash, the different types of image to eMMC and SD card. They don't show you that the tool called UUU is available for Linux. It only really shows, well, it says to do this in PowerShell as administrator, then uses / format. So it's obviously available for Linux. We've got some Windows things again there. That is through the NXP IMX MFG Tools repo. So you can download that from here under their releases, and that's what you use to flash it if you're not using the SD card image, which you can just extract and dump straight on an SD card. So Debix makes some really cool hardware. We've looked at the first iteration, which is the SOM A. That's the 4-core version. It's the one that's got the 2.3 tera operations per second, or TOPS NPU. It's the one that's got the real-time operating system, the dual ISP up to 4 gig of RAM, can run Windows. That's an awesome beast of a thing that we will give away some of in the next video. In case you're wondering, the reason is US presidential order, whatever it is, that stopped shipping to the US. That means I can't ship products to my store. I've had to put that on hold. It means I can't give you products. It means there's all sorts of crazy stuff going on. That is due to be solved by the end of that this month, at least for shipments from Australia through Australia Post.IU. So I'm working with them to get that in place. Once I can ship these to whoever wins it, once you do win it, you'll get some. That being said, it is time to move on. So my final thoughts are that this is a bloody impressive product with a very specific use case, and I do quite like it. It's not without its issues. It's it doesn't come with a heatsink. It doesn't come with a case. It's not designed for everyday use. And I have had some minor issues with HDMI, as I mentioned, with my Blackmagic and with the USB ports. I'm not sure if that's just waiting for the OS to boot or not though. And I'm continuing to talk with Debix about that, and they're continuing to improve their software images, their board revisions, everything like that to support it. So all in all, I like this board. I like working with Debix. They're paying me to make this video, but they're not paying me to say that. And I have to thank all of you for your support and for coming along and supporting these videos as well, because they do take time to make. Go check out that Zia 2 video where Patch talks about what actually goes into it sometimes. I'm not spending his money, of course, but they do consume time, they do consume money. So thank you to all of you for coming by. Thank you to Debix for supplying these for us to test out. Thank you to the patrons. If you weren't aware, I have a Patreon and I've got some more members now, which is great. It's slowly growing, but you get early access to everything in here. You get, oh, there's my 3rd birthday post. You get advertisement-free video links. You get access to chat. I'll help you with your SBCs. And it, of course, supports me. It starts as little as $3 a month in Freedom Dollars, which is about $4 a month in Australian, all the way up to you earn too much money or you really have some strange fetish for me. I hope that gives you more information. I hope you enjoy these Debix devices, and I'd really love to know, if you want to let me know below, what your thoughts are on this. Like, what would you use it for? How would you rate it if we were going to start putting carrier boards and compute modules or SOMs on the tier list? Yeah, it's different. It's awesome, and especially with things like 4G, dual CAN, dual ISPs, it does some amazing stuff. So I'm looking forward to testing out the modules B and C in the next video. If you want to make sure you don't miss those and the giveaway, don't forget to like and subscribe as usual. The algorithm needs it. Hit the bell though to be notified when the next one's coming out, especially if you're not on YouTube often. It also looks like I'm about to hit 10,000 subscribers, so go me. That's a pretty cool little milestone all in itself. Thank you again. Have a lovely afternoon. I'll see you in about a week or 3, depending on how my weekend goes. Cheers.